All right, so when we start solving an equation, we want to simplify each expression. On the left side, you'll notice that I have 4 times the x minus 3, so we'll distribute or expand the 4, giving me 4x, and then 4 times negative 3 is negative 12. Well, the right side is exactly the same thing. So these are identical expressions. If we do go forward and we want to isolate the variable term on one side, so we'll attach a negative 4x term to both sides, I would be left with negative 12 equals, on the right side, negative 12. So this is an identity because the statement is true for all x. This is a true statement for all x. So the answer would be all real numbers. All right, so again, you'll notice that here the variable terms dropped from both sides. All right, let's see if that happens again. In part B, or in B, again, we want to simplify our expression on each side. So we want to identify the terms. I have 3 terms on the left side. So I have a 4. I'm going to distribute this negative 2 to those 2 terms. I'm going to have a negative 2a and a negative 10. And then the last term is negative a, so I have that one, equals. On the right side, I have a negative 5a term. And then again, I'll distribute negative 2 and expand these terms. I get negative 2 times 1 is negative 2, and negative 2 times negative a is positive 2a. So if we collect like terms on both sides, negative 2a and negative a is negative 3a. 4 and negative 10 is negative 6, and that's going to equal negative 5a and 2a is negative 3a and negative 2. And again, we notice that we have the same variable term on both sides. And if we want to eliminate or isolate the variable term on both sides, we're going to add 3a to both sides. And by doing that, what's left is negative 6 equals negative 2. So this is a contradiction. It's false. Negative 6 is not equal to negative 2. So therefore, my solution is no solution. So there's no values for a that make the left side equal to the right side. So let's try the last one. The last one will give us some practice in clearing fractions. So I want to clear fractions on both sides. My common denominator, my greatest common denominator would be 12. So I'm going to multiply both sides by 12. When I distribute to both terms, so this first term, if I distribute, I only have negative 1/4 times 12, so I can cancel the 12, leaving a 3. This would end up being a negative 3, and then that would be times 1 minus x. When I distribute the 12 to the 1/3 x, the 3 will cancel, leaving a factor of 4. So this term would be a positive 4x. On the right side, again, distributing the 12, the 6 would cancel with the 12, leaving a factor of 2. So this term would be 5 times 2x, or 10x. And then when I multiply 12 times the negative 1/4, distributing here, the 4 in the denominator will cancel with the 12, leaving a 3. I don't know what happened there. Leaving a 3. So this would be a negative 3 term. All right, so on the left side, we'll expand. Now that all my fractions are cleared, so negative 3 plus 3x plus 4x would give me 7x and minus 3. And that's going to equal 10x and minus 3. So if I continue to solve, you'll notice this is not like the other ones, meaning the x terms do not cancel. I actually do end up with 3x on the right side. But if I add 3 to both sides, I get 0 equals 3x. Well, this one I can still solve for x by canceling that factor of 3, and my answer would be 0 equals x, or x equals 0. So this is not a contradiction or an identity.